toolchain finally working for this one. It's a microcontroller, it's a pretty hefty one. I looked and they're actually like $12 each. Mouse are still just that. So these are the ones I found in a skip or a dumpster, depending on where you're from. I've had 3 of them. They had motors, stepper motors, small ones. It was for opening and closing a ventilation shaft. So yeah, 3 of them. They came with these rather long, just for power USB things. They have 2 buttons. They have two colour LEDs. They have an external flash SPI. They have a Sub-Ghz radio chip there with an antenna socket there, and this is an antenna here on the board. Yeah, they're great. So I've reverse engineered the board, figured out what's going on, erased it, had a nightmare trying to set up a toolchain from absolutely zero experience with pretty heavy embedded chips. These are they're way more difficult than Arduino. It's a similar concept, but just way more difficult to set up. But it's cool, you know. It has been a head wreck, but I've learnt a lot. I soldered that on once I figured out that was the programming port. That's an SWD port, single wire debug port. So what did I do? I couldn't do it with. I tried to program it with a J-Link clone. It was an ST-Link clone, which I'd made into a Sega J-Link clone, which you can do, but it will only let you Sega J-Link ST products with it. So, because this is an NXP chip, it's not an ST chip, so a clone of a clone won't let you work with this one. So I sprung on a J-Link. It's around somewhere, I don't know where it is. So then I made a little connector for this, not knowing that the J-Link has a tiny connector and it fits perfectly to this size, so then I took it off. This is the chip. Yeah, this is the large quad flat back package, 100 pins. You can orient it as you want it. So there's pin 1 up there. I'm working off of I don't say off of, it's not right, it's off. I'm working from, that's what we say. I don't know, I've watched too many other fucking videos, people saying off of. That's really not how you say it. Preview. Here is my picture that I've been working from. So that's pin 1 down here. And then, you know, yeah, you can orientate that one how you want. I think that's how I took it. And I've got notes on there, you know, just about what it's doing and what the things are, and the, you know, just reverse engineering notes, basically. So let's reorientate that one the same, because then, yeah, I can zoom in and stuff and check stuff out. So let's just slide back to that one. Yeah, so now you can say, okay, here's pin 1. You got the VDD1, there you go, dedicated power supply. You can't change all of these, some of these are fixed. So you got the big list down here. I've routed or enabled all of these green ones, basically. So they're all like the standard functions, basically. You've got buttons, there's 2 buttons and there's 4 LEDs, there's 2 twin package LEDs, and that's what I've set up so far, as well as like reset pin, single wire debug pins, stuff like that, that's kind of already set up. Not able to be chosen. So what if you want to set something up on here, you click it on there and then you can select which one you want it to be. There's loads of choices, so you've got the SDA MOSI in out, or SDA RXT on that one, Flexcom 8. So you can multiplex these pins into anything you want, basically. Programmable interrupt, I think that means programmable interrupt. There's some kind of an interrupt pin. You would use that with the buttons. DMA pins, triggering, analog to digital converter pin. So yeah, you can see that there's a ton of choices for those, or you can disable the pin, and the default one is here, which is what it sets to after it's been reset. So that's just a general purpose input output. So then we're not going to route that at all. And if you want to route it, just click that and then it comes up, and then you can make some more notes about it. So once you've selected that and you've said, right, okay, I want that to be the reset, and yeah, you know, you can see that these things are lighting up. These are all the EMC pins. This is all the IC0, Flexcom 0, 3, you know, whatever. You just can see what they're all lit up when they go green when you've routed them, right? And then they come in the bottom here, and then you can I'll just make that bigger. Then you can specify, right, you got the label, you can have a drop down in the end. From those you can say what ports they are, so you kind of have to set this one up as well. So these are the LEDs, so you know, 1A red, 1B green, and then you've got the direction, their outputs, and the inputs, because there's the buttons. So you got to use a switch 2, and then I'll define the function in the software later. Switch 1 and switch 2, because I don't know what I want to have it as yet, you know. But the relays are always going to be red and whatever, so I always want them to start at 0. Hang on a minute, these seem to be just. No, wait, what? Oh, okay, I find it just was a visual glitch. Okay, now this is a bit confusing. This is like pull up on the buttons, right? Sorry, here. This is pull up on the buttons, and then these ones say inactive, but you don't actually need anything on the output. It's just the input bias, really. So, you can say like no initialize, no initial state. You can pull down, pull up, but you don't want to pull down really on the output. Maybe, I guess, but anyway, I put them to inactive, and that seems to work fine with a logical 0 as a beginner. So, I wonder why that one's in italics. No, the other one's not. Okay, well, whatever. That's weird. It's a bit hard to see when they're like, because that looks like it's on that, but that's actually the. And you're like trying to get it back. See what I mean? It's like just gonna type it in instead. It's easier. So okay, so let's pretend then that that was an actual change instead of just changing it back, right? So it creates these PIMUX file, and then it'll slam that in with the rest of your code and compile it. So, and then you've got the H, and it'll put that in as well, you know, all the defines and the includes. So here you've got like the initial pins, user, switch 1, GPIO, and then pin mask. I think that's like the pull up. So yeah, look at all of this code it writes for you based on the instructions that you've given it in this little tool. So yeah, I mean, you can do this from scratch, but look at it, man. It's like, fuck that. It's like so much code. I'm sure that you can do it with bare metal and it will come with a more, you know, streamlined version of it, but yeah, forget it, it's fine. This is a powerful microcontroller, man. It's like, you can cope with a little bit of a, maybe not bare metal optimized code, it'll be fine, you know. So anyway, then you would go update code like that, and it'll say no change, no change. Here you made a little change, where we just changed that thing backwards and forwards, I think. Here you got clocks, peripherals, TEE is never going to come. Device configurations, never going to come. because they're not compatible with this device. The processor is not supported. And then, yeah, so the configuration synchronized with the source code. So yeah, that's the only change, and then we just say change, and then he just changes it, he rewrites that bit of C and H that I was just showing you. And then you go, it drops you back into developing, and that's the code again. And we can enter, this isn't optimized code or whatever, you do need these 3 arguments though to write to any pin. So this is just Blinky basically. So that's what it needs to include, and then once I've got these set up, then I go on to the clocks and check out the USB and the SPI clocks set up. So that should be a barrel of laughs, I'm sure.